Hello, thank you for coming. This is the Vitrek PA900, 910, and 920 advanced session on how to use the integrated oscilloscope and measure power inrush current. So this is the typical screen that you see when you're looking at data. Right now I've got a 920 that I'm actually going to use as the load. Um, but I'm going to start off with the scope and show you a little bit about the integrated scope. The scope's a little unusual. I've used a lot of scopes in the past, and the thing about this scope is, to begin with, instead of being an 8-bit oscilloscope like you find in, say, a Tektronix oscilloscope, this one is 22 or 24 bits, depending upon how you, which card you put into the system. Now, if you pick on traces, one of the things you'll see is instead of being a 4-channel oscilloscope, you can actually have 6 traces, and you've got a couple of different VPAs, so you can actually have as many as 12 traces like a 12-channel scope, but you can do it 2 at a time. Now, what you'll see in this is that I've got channel 1 volts and amps turned on, and I've already preset the division just so that we can get a nice display, and I'm going to return. So the scope can be used in a couple of different modes. One is this, this is called a cycle view, and in a cycle view, what it does is it automatically sets the time base up and the auto scale up so that you get one cycle displayed at a time. But for what we're going to do, we want to measure inrush current. We're going to come on over and we're going to tell it to go into the oscilloscope mode. And so the first thing you want to do is you want to come in here into the in the traces and turn on the correct traces. And then you want to come on over here and you want to do the config. And in the config menu, you can see that you've got some the ability to set the trigger. In this case, I've set it to trigger on channel 1 current. And here's your different choices. Since those are the only traces I have turned on, that's what's available. And I can set the trigger level. I can set it for DC rising, falling, or an absolute level, or even on the rate of change of the trigger. So I can also have pre-trigger and post-trigger positioning. Right now I've got set for 50%, but I can change that as well. And then on the time base, I've got it set preset. And the main thing to know about the scope mode is it's got a normal scope mode and then inrush mode. And in the inrush mode, it's going to look specifically for the inrush. So I'm going to return it like this. And I've got it in single. I'm going to just arm it like that. And then now what I'm going to do, we also, in addition to the oscilloscope, there's also another mode specifically for inrush current. And the way you do that is you just hit this power data. And then this is the normal mode. And by the way, I can turn on more detail if I want to do this. This starts giving me, it breaks it down by AC and DC and the various different peaks if you want more detail. But the one I'm going to look for is called inrush. And I'm going to clear the values. And so then what I'm going to do is I'm going to come on over and take a look at the scope. And then what I'm going to do is I'm going to turn on my load, which is the 920, and there it is, it captured it. So that's how easy it is to do this. If it's basically, if you grab this cursor, you can move this cursor on over to the exact trigger point right like this. And right there will tell you that it triggered at the current I told it to trigger at. And it's looking, everything from here onwards was after the trigger. This is the pre-trigger information. And if you go over to power data, you can see that it captured that the peak power during the inrush was 0.548 amps peak. And that was the peak voltage and the peak current. So that's how easy it is to use the oscilloscope and to do the inrush measurements that you need.